our senior design project is a lunar excavation robot, which we plan on submitting to NASA's Lunar Robotics Competition. NASA's Lunar Robotics Competition is a university-level robotics minding competition aimed at students within the STEM-related fields and majors. And the aim is for students to design and build a lunar excavation robot dubbed Lunarbot in order to compete. And NASA benefits from this competition by being able to observe and possibly absorb new innovative ideas from competing teams. We want to enter this competition to not only test our capabilities in building a robot, but at the same time to further stimulate interest within STEM-related fields, to explore robotic design innovation and possible robotic autonomy, and also to utilize our accumulated engineering knowledge. All right, NASA has set some guidelines for designing our robot. There has to be safety inspection. There's size limitations as well. There's a maximum weight of 80 kilograms for a robot. The robot has to collect at least 10 kilograms of this simulated lunar soil within 10 minutes. And the robot can either be autonomous or remote control, and it has to run off its own power supply. The robot needs to be able to communicate within an allowable data range, and it could relay either real-time power consumption or possible camera feeds if it's going remote control. And the robot's operation has to be relatively dust-free. It can't cause large dust clouds. And there needs to be a commercial kill switch on top of the robot of at least 40 millimeters in case anything should go.
This is the obstacle course that we'll be competing on. We have 4 random positions that will be placed, and then we have to travel through an obstacle course to the mining area. And to the mining area, collect at least 10 kilograms of the lunar soil, bring it back to the dump bin. This is our proposed design. We're using a track-based wheel system in order to maneuver the course. We'll use an auger dredge coupled with a vacuum system in order to collect the lunar soil. The auger dredge will be placed on a tilt, which will lift as you travel throughout the course to prevent any difficulties in travel. Once at the big site, it drops, it'll activate collecting the soil in a covered dump truck type bin, lift up, and then travel back to the dump site. Once at the dump site, the dump bin is placed on linear actuators, which at a certain height, a tilt will be engaged, automatically dumping the soil. This will, which also allows us to save on weight because we're using one motor for multiple functions, which was a main concern in previous years. And these are previous designs. This is FIU's Pantera, which went to competition and did very well as the competition winner in 2010.
So as mentioned previously, we're trying to enter into a mining competition, and how does this help the world? We're trying to basically look into markets such as like in Western Australia, where there's expanding sites for iron ore, and because of the growing mining sites, more and more people are being put at risk. But what Caterpillar and Komatsu are doing, they're implementing autonomous systems. An example of that is Komatsu's autonomous haulage system. Basically, what we're trying to do is kind of the same thing, get from point A to point B, and our robot will dictate where to go and where not to go. And then once at point B, do what it needs to do what it needs to do, and go back. All the while communicating with the computer, just on board and with master computer. And this is our projected timeline. This summer we're focusing on acquiring components such as the auger dredge, and acquiring the materials for fabrication, and hopefully by the end of the summer, get it ready for testing and ready for competition.
When's the competition?
The one that we would be competing for will be next year, so 2014.
Okay, do you have any questions?
All right, go ahead.
Who's funding it? How you funding this?
We are, this previous design, we are actually taking some components from them. Aside from that, I believe this currently lost sponsorship from McNair to, I think, Budget Cups. I'm not sure if they clarified that.
So budget cuts, so, just, trying to get sponsorship from them, but, due to, McNair is a government-funded program, so no government cut funding recently, so they're kind of tight. So that's not like, just giving out, but other than that, at the current moment, we're still for sponsorship.
They do a lot of work with NASA, so maybe they might be able to give you some kind of funding on their, they're not government, they're not a government agency, they're a private agency. Maybe get lucky out right there.
Yeah, right now, I'm trying to collect like a list and, go through, trying to like have all my research and everything done so that I can start following.
We have been looking at individual park prices in case we have to fund this out of pocket. We did find an auger, this red Archimedes screw. So it's made of steel, and it's stainless steel, and it's roughly 8 pounds. That's what we can acceptable. And it's only going to cost us roughly $70. So buy the part, and you can take it to machine shop. Cut it.
Okay.
So I have a question about ground clearance both in transportation and with your specific design. So what happens when a big rock is in the way of whatever is in front of your proposed design? It seemed to me the winner last year has these nice big wheels with this big high ground clearance, right? So why did you specifically choose this design?
Originally, we were also thinking, because this is, I mean, there's a lot more we can do with the frame, because this is just a basic frame just to show like the main components. But we want to hopefully have a pretty big ground clearance. From researching previous competitions, I'm pretty sure we could like clear a certain height just off of this design. But after more research, we could probably add to the suspension, hopefully adding like a, probably some actuated, like a lifting suspension, whereas it'll travel at a certain height. Once at the dump site, it can drop down.
So what about this? What if you put a big wedge right in the front of that thing, but still had an opening underneath? So the wedge would wedge out any rocks on either side while you're driving it along, but you can still suck up whatever
That would work.
regular would work, right? So that's just a thought, I don't know, but.
That's a good.
The
I don't
other
understand.
question with it is that
Like
because
how
of the way the other
Yeah,
car
yeah,
is,
exactly, right. Apply.
what if you come across a surface that's flat? You're not gonna pick up anything because you've got the shield set. Go back to that last slide. The shield set such that the auger isn't even into the material
Right.
underneath. Where the auger should, you shouldn't have to need a driving force to drive the auger into the material.
Mhm.
The auger should be set so that it's just below the bottom of your guide.
I see what you're saying, so that lower.
Just below, because it's got to get into material. You can't get
Yeah.
into material.
Yeah. Should have some sort of actuation there.
Definitely.
Yeah.
Well, I know with the actual, like, we're still researching the certain mechanisms in order to dig, because one of the things we're trying to avoid is using multiple motors, because then it adds to the coding
Sure, yeah.
as well as the weight. And that was one big problem in previous years. They said if you can use one motor for multiple functions, you can cut down on a lot of your problems. We're still, but that is.
So you may be able to engage some driving system to lower down the auger itself too, right? So you have a little clutch system to keep one motor, but then just engage that one clutch. Yeah.
More questions?
Why did you guys decide to go with this track system as opposed to something else? I mean, what, having been in the military, I've seen what tracks can actually do, especially when you throw a track, and you know, it's not exactly, the lunar surface is not exactly very forgiving in terms of tracking systems. And the question is, why did you decide on a track? And from the looks of it, it looks like you're looking at a very thin track, which could be even more problematic.
But when we made this design, we were still looking at components. We found one that's a little wider, but I understand what you're saying about the tracks, which is one of the reasons why we tried to add to this as well, because just in case you throw a track, it can possibly, and we're trying to have motors to drive at least the front and back mechanism. So say we did throw a track, then hopefully the wheels could maybe help some. It would take a loss significantly, but at least be able to travel in order to complete the competition. But the previous year, they designed a wheel, one of their own wheels, and it didn't work out so well. From my previous knowledge, I think they threw like one of the wheels collapsed. Yeah, it collapsed. So that's kind of why we didn't want to copy their previous designs and wheels. And looking at competitions, a lot of times, if you get into a soft patch, if you have just 4 wheels, it kind of gets, it's possible to get stuck, especially while you're trying to dig and collect fluid.
Well, one of the things that I'm going to suggest, I'm sure you may have already thought about it, is if a track is thrown, okay, and you do power the wheels, you're going to have a system that does this.
Because then one is on track and one is on.
That's right. Okay? So you have to take that into account as well.